Okay, here is a question that was asked. It says resolve, but I am guessing the real question says solve the weight of the crate into two rectangular components, keeping it at rest. Include a vector diagram in your solution. I need help with this ASAP, please. All right, yes, let's answer that question. These are classic questions. This is actually a physics question, but it does deal with geometry and vectors. So basically, as you can see on the screen, there is an inclined plane that I drew. And now we're going to create our crate sitting on that inclined plane. And we want to include a diagram. So we have the incline, we have the crate, and now we can add theta. In this case, our theta, or the angle off the horizontal, equals 12 degrees. Now it's imperative whenever you create these crates sitting on an inclined plane problems is to establish your X and Y coordinate. We're going to establish our X and Y coordinate this way. We're going to acknowledge that the crate or the weight of the crate is along the X and Y coordinate and the normal, which is perpendicular to the surface. The normal is off the Y. So we're going to mark this part Y, so it can be along the normal. And allow me to draw a little bit better. You want to draw the Y component along the same angle as the incline. And then the X will be the other component. And we know the weight of the crate itself is going to go straight down this direction. So because we establish our X and Y coordinate, we're going to mark them. The Y is going to be not perpendicular, excuse me, along the same line as the normal, the Y part of the weight, and then the X part of the weight is going to be along the inclined plane. And so we can see here that we can establish two angles. We have two different angles. And let's mark the value of each angle. First, the angle that is from the weight to the X component, this angle right here, we're going to call that alpha. And then this angle right here, from the weight to the Y component, this will be our theta. Keep that in mind. The angle from the Y component to the actual weight will always be theta, the theta that's given to us. So how do we find alpha? Well, this creates The W, or the weight, which is just a reminder, which is M times G, the unit weight, that creates a 90-degree angle. So 90 degrees equals the alpha plus the theta. So if we subtract both sides by theta, in this case, our theta is going to be 12 degrees. 90 minus 12, this is going to equal 78. 78 degrees. So let's go ahead and plug in what we need to plug in. Or let's go ahead and solve for this. So this is where we're going to introduce our trig functions. We're ready to solve for the components. So in reference to theta, x weight of y, the y component, is cosine, or it's next to this angle. So we're going to write wy equals the weight times cosine theta. What about the x component? Well, if the y component is cosine, then the x component should be the sine. Now we have both legs of this triangle, because remember, the vector components make a right triangle. So now we have both legs. One is weight times cosine theta, and the other one is weight times sine theta. So let's solve for the components. Let's solve for the y component. The original weight of the crate is 550 newtons. And we're going to multiply that by cosine of theta, which is 12. And when you plug that in your calculator, you should get 537.98 newtons. Next is the x component of the weight, which is 550 newtons times sine of 12, which will get you 114.35 newtons. Now, based on this problem, the weight value, or what's given to us, the information that was given to us was that the weight of the crate was 550 newtons. And I'm not sure if there's a period here after the 50. And then the theta, or the incline, was 12 degrees from the horizontal. So we're going to round, we're going to use significant digits, and we're going to round up to 2 significant digits. So this answer should be 540 newtons. And the other one should be 110 newtons. And that's how you find the answer of the components, and that's how you draw the diagram.